Okay, this will be the third and final video for the Thermal Solutions EVCA boiler. Let me get back to the wiring diagram here. And I want to look at the second diagram down here, the second page. I will kind of zoom in a little bit on this. But here is where you see in the first diagram, or I guess what we covered mostly in the first page of the diagram, was this board right here. Here is the sub base for the RM7896D 1027. Here are all the relays. Here are all those terminal connections. There's the power fuse. Here was your three terminals for the power coming in, 120 volt with ground. There's your low water cutoff. The thermal fuse for the vestibule. Here's your probe for the low water cutoff. Burner on-off switch, which is on the front panel. Here's your flow switch. I don't know, maybe we haven't explained this well enough, or maybe I should explain it another time just to make sure everybody understands. A low water cutoff and a low water flow switch are two completely different things. This one measures the level in the boiler to make sure there is actually water in the boiler. This one measures whether or not there's flow through the piping, and the flow switch is always going to be mounted on the piping, probably leaving the boiler on the outlet pipe. But one will shut the boiler off if the water level is low. This one will shut the boiler or burner off if there's not enough flow going through the boiler. Here is your combination high and low gas pressure switches here. Here is the high limit safety, and then the operating limit. It's required on all boilers that they have a separate high limit control. We talked about this when we talked first about the triple flex boiler having the dual element thermistor for safety circuit, but this Thermal Solutions is sticking with a standard Honeywell high limit, and then they have a secondary operating control here, even though over here on the TSBC you can set a set point. It has a system temperature sensor that it can monitor and start and stop and modulate the blower speed based on a set point and the temperature here, but you still have the operating and high limit controls there. Here's the combustion air flow switch. Make sure that the combustion blower is running. Your primary and secondary gas valves, the pilot gas valve, the ignition transformer. If you remember from the traditional flame safeguard, these are the three outputs that it controls. It tells the ignition transformer to provide a spark, opens the pilot solenoid valve, proves that the pilot gas or pilot burner has lit. There's pilot flame there, and then it shuts the ignition transformer off, and the pilot flame lights the main flame, and then the pilot shuts off. That's typical for the sequence of an RM7896. Here are the terminals going out to communicate any type of a control status. Your blocked filter switch, 24 volt transformers. Here's the speed signal to the VFD. If you remember, there was a stop-start signal for the VFD, or maybe that is the stop-start signals for the VFD going in on 1 and 2 right there. And then here is the actual speed signal coming across from the TSBC controller. So let's move over here. So that was pretty much the board that holds the flame safeguard on it. Here is the TSBC controller, your set point. Here you have an optional outdoor air sensor if you want to do outdoor reset. And outdoor reset means that you're going to make the loop water temperature higher when the outdoor temperature is colder. And here's the system loop sensor. Here's different inputs for domestic hot water, like you saw on the triple flex and the clear fire boiler, the controllers on it. Local remote switch, so you can have remote stop start. Here's your remote enable. all those features like you had on the Honeywell R7910, I believe, the Solar controller. Here's inlet and outlet water temperatures. Those are factory installed, and you can read the inlet and outlet temperature right on the front of the display. And then here is some outputs for auxiliary equipment. Remote control for a 0 to 10 volt input. This I think you saw that on the Solar controller, the Honeywell controller for the triple flex and the Clearfire boiler. You could also send it a remote signal to vary the firing rate. Here is the I don't know why they call it. Well, I guess it's tied to the Honeywell control panel. But here's the silence button, the alarm bell, and hopefully you remember the little diagram that goes along with that. I guess that's pretty much it. Down here is the UV scanner. I think this is the one thing that's a little bit different. On most of the flame safeguards we talked about previous to this, we were doing flame rod, and this one actually uses an ultraviolet scanner. I want to take a quick look at the manual here, and I see how much time I got. I got plenty of time left. This manual goes through, there's a lot of detail there on dimensional information, proper venting of the flue, the heat exchanger. Here's where your system return water comes into the secondary heat exchanger and goes back out to the system supply, but it also will come up and go through. Here's the pump, takes the water from the secondary heat exchanger up into the boiler and then back out that way. When you need the temperature of the water going into the boiler to be hotter, it can recirculate some water right here and not pick up as much water here to keep the primary heat exchanger from condensing. That's an important thing. Any condensing has to happen in the secondary heat exchanger because that's where the drain pan is. You can't have condensing in there, so they try and keep the water temperature right here at probably 125 to 130 degrees minimum, and they do that by either recirculating hot water through the mixing valve, or if it's not recirculating, it's taking some of the water off the secondary heat exchanger and going in. One thing I was looking for on this literature, and I did not find it, and I'm not really sure why Thermal Solutions doesn't give you information like what the thermistors what type of thermistors they use. You know, they show in their diagrams, and there's some more pictures of the diagrams in the operation manual, but it doesn't necessarily tell you that it's a 10K type 2 or 1,000 ohm type thermistor. It just doesn't really tell you that. It just shows you that there's a remote system sensor or an outdoor temperature sensor. I guess, you know, you could look at the sensor and you could probably ohm it out and figure out what type of sensor it is, and that's something I would like to be able to show you in class, because it was something we would do in class, is to actually measure and simulate thermistors, you know, figure out what they are. But for some reason Thermal Solutions doesn't spell out in their literature like a temperature resistance chart like you would see on most manufacturers' information. But here's kind of a boiler sequence, interlocks, limits, relay outputs, things, and how things happen. You know, the blower voltage, blower high speed, blower low speed, kind of how things work in sequence. Even though they're using a traditional flame safeguard, there's a lot of things in there. Here's the LCD display. It will tell you if the boiler is disabled, whether it's warm weather shutdown, which means that the outdoor temperature is higher than than a temperature you need to run the boiler. A lockout condition, whether the boiler's in standby. All this information to tell you whether the pilot's on, the low fire ignition, main ignition, All of this stuff will show up on the display. Here's some service and maintenance information. Before I run out of time here, I want to get down to the parts list. Thermal Solutions is really good about listing all their parts. There's a kind of exploded view of the heat exchanger. Here is the blower assembly. This little wing nut here is what holds the filter element to the boiler. Here's the actual air filter part number if you had to order a filter for an EVCA 3000, a 3 million BTU EVCA boiler. That would be the filter part number. The pilot assembly is, let's see if I can find a picture of the pilot assembly. Yeah, maybe they don't show that separately. But when you get down here to the control panel layout, here's the board with the flame safeguard on it. Let's see. It doesn't show. There's the VFD. It's actually inside the cabinet. There's your ignition transformer. Of course, the control panel is mounted on the front. One thing I thought was interesting here, when it lists the components for the control panel here, there's the flame safeguard. It does list an RM7840L, which is a full function programmer, if you remember from your traditional flame safeguard lesson. That is available if you had the need for POC, proof of closure. You have to have a full function programmer for that. And this is low fire proof, LFP. That is the kind of stuff that you would get, or the features you would get with a full function programmer. So they do, what we looked at on the wiring diagram was a 7896D traditional flame safeguard, considered an advanced primary control, but they also offer it with the full function programmer, the RM7840L, if you required to have POC and low fire proof, proof of closure and low fire proof of start. Here's a Honeywell high limit L4008E1313. You could go to a local supply house and buy those. That's a Honeywell part, the FS4-3. I hope you never forget what an FS4-3 is. That is the most common flow switch in the world, and you've already seen pictures of that from a previous lesson. Here's the pilot assembly here. This is the ultraviolet scanner. There's a stainless steel nut here, and you loosen that up. When you tighten this down, you never tighten these down with a crescent wrench. You just tighten them down to their finger tight. There's a washer inside there, like a hose washer. You know, when you put a hose on a hose bib, you don't have to crank it down with a pair of channel locks to get it to seal. All you have to do is get it tight. You really don't need to get on this with a crescent wrench, because you'll crush that rubber washer, and you'll take the chance of breaking the glass that the ultraviolet scanner is enclosed in. This shows the ignition igniter probe coming down, and where it sparks to. There's the ultraviolet scanner. If you wanted the ultraviolet scanner, I would say you probably will find a part number on it. I'm sure you'll find a part number on it for a Honeywell part. But if you ever have to call Thermal Solutions for help, I'm sure somewhere in this manual they have their phone number. But they are, from what I remember having to call them, there was a lady named Joyce who knows everything about every boiler they've ever made. She does all their training. She does all of their tech support on the phone. And she has the answers to any question you have if you ever have to call Thermal Solutions for parts or service or tech support. She's very good at knowing their product line and what you're asking before you even ask it. So I'll make up as many questions as I can think of for these 3 videos. Hopefully this we'll probably get off of boilers here before too long and start doing wiring diagrams for other pieces of equipment. But let's think about that for a little while.